Hi, I'm Bob Tabor with Developer University. For more of my videos for beginners, please visit me at devu.com. Now in this lesson I want to get back into talking about C#, the syntax, and we're going to talk about declaring variables, how to choose the right data type for your new variable, and then also how to initialize variables with values. So to begin, let's take a look on screen. If you've ever taken an algebra course, hopefully you've seen something like this where you're asked to solve for the value of x. And hopefully without a lot of thought, you're able to see that x equals 7, right? So using that same thought process, take a look at this little snippet of code on screen. X equals 7, y equals x plus 3, and then we're going to do a console.writeLine with the value of y, and hopefully you look at it for a moment using your existing knowledge of algebra and you think to yourself, well, then it's going to output the value of 10 to a console window, right? Exactly. And so my point is that C#, first of all, is human readable. It's got a few things that might be a little foreign to you, like the semicolon at the end of the line. However, for the most part, I'm willing to bet that as we go through this series of lessons, you'll be able to understand what the code is doing, for the most part, even before I explain it to you. So it's really not that hard. And then secondly, it's probably very similar to things that you've done in the past, like working with math and algebra and things of that nature. And so if we're looking at the C# code, the x and the y in this context are referred to as variables. And a variable is simply, under the hood, a bucket, I guess you could call it, in the computer's memory. And you put things in buckets and you dump things out of buckets, right? And so we can put values into a given bucket in the computer's memory, and we can retrieve the value out of that bucket. We can even replace what's in the bucket with something different, right? And so that is what you use a variable for. And so this particular situation that we see on screen, these buckets are just holding numeric values. However, we could create buckets that are just the right size for almost any type of information, whether it be individual alphanumeric characters or strings of characters, strings of alphanumeric characters, like even entire sentences and paragraphs and even books. We could also create buckets that are just the right size for dates and times, buckets that are just the right size for really massive numbers, or even create buckets that are just the right size for numbers that have a lot of values after a decimal point. Now, in this case, what we would expect to see here is that these two buckets, the bucket that's labeled X and the bucket that's labeled Y, would hold numeric values because we want to add numeric values together, right? And so we know that, but how do we express that intent in C#? The instructions that we write in C# will ultimately, after a compilation step, they will ultimately be executed by the .NET runtime that we learned about in a previous lesson. And part of its responsibilities are to make sure to allocate memory for our variables in memory to hold the right kind of data. So here we have two data items, an X and a Y, and we have to tell the runtime that we want to allocate some space in memory that's sufficiently large enough to hold numeric data, like the type of data that we want to work with here in our application. But how do we do that? Well, that's the topic of this lesson. So to get started, what we want to do is create a new project. And here again, I'm going to go to File, New Project. We will go to the New Project dialog and make sure we select the Console Application Project Template. And here we're going to rename this and call this project Variables, and then click the OK button. And Visual Studio goes to work, uses that template, and creates a new solution with a project. And as you can see on screen, here we are back in our familiar program.cs. Obviously, we want to work inside of our static void main in between the opening and the closing curly brace, just like we learned about in our previous lesson. All right. So before we get started, there's one big takeaway from this lesson, and that is that a variable is simply a bucket in memory that you can put data into and retrieve data out of. But we have to tell the compiler, we have to tell the .NET runtime what size of buckets that we want to create. So we have to declare our variables. We have to create those buckets and then give them some label that we can refer to them with from that point on. Now, before we get started here typing some code, all the same rules apply in this video that applied previously. So you have to type the code exactly the way that I type it. Take the time, develop the skill of identifying differences between even small differences, a different in capitalization or in spacing or the various special punctuation marks that we use while we're writing code. Develop that skill to identify the differences between what I write on screen and what you're writing in your copy of Visual Studio. All right, and if you see a little red squiggly line, you already know that there's going to be a problem there, right? So that gives you the clue necessary to go and focus either on that exact character or in that vicinity and use your detective skills to figure out what it is that went wrong. Okay, so now let's go ahead and we're going to create two buckets, two variables, and define them in such a way that they're going to hold numeric values. So we'll start with int x and int y, and it's as simple as that. So here, to borrow the explanation that we used earlier, we are asking the .NET runtime to allocate space in our computer's memory sufficiently large enough to hold numeric values. Now we're asking it to create these two buckets, and eventually we're going to put values into them and read values out of them, but at this point we're just declaring their existence and saying here's what we need to work with. And then after we've declared them, after we've created them in this manner, then we can begin to work with them and assign values, retrieve values from them. But most importantly here, I'm telling the computer that I want to assign integer values into those variables. And an integer is really just a mathematical term that refers to a whole number that's within a certain range. So no values after the decimal point. And as far as C# is concerned, the values have to be between a negative 2,147,000,000 and a positive 2,147,000,000. That's the size of the bucket that we have to work with. If you need to work with much larger numbers, then the int data type is not the correct data type for you. There are other data types to choose from, and we'll learn about some of those a little bit later. If we needed to work with like money values where you have dollars and cents or pounds and pence, then the integer is not the right data type to work with. Okay. Let's continue in our application, and this is basically just to continue what we did in Notepad a few moments ago. So x equals 7, y equals x plus 3, and then we want to do a console.writeLine with the value of y. And then remember, we want to do a console.readLine so we can actually see it on screen without it just flashing and going away immediately. So let's run the application and make sure we get the value that we're expecting. And hopefully you got the value 10 in your copy of Visual Studio just like I got in mine. If not, again, make sure you double check your work against mine. All right, so after we declared the variables in lines 13 and 14, then in lines 16 and 17, I'm doing assignment using the equal sign. Now in this case, we don't really call it the equal sign, we call it the assignment operator. We'll learn about operators in the next couple of lessons. This particular operator, the equal sign, means take whatever is on the right-hand side and assign that into whatever's on the left-hand side. So we're going to say, give me the value of 7 and assign that to our variable, our bucket named x. And the same thing would be true here with y. We're assigning a value into the bucket named y, but we have to do something interesting here. We have to actually retrieve the value of x from memory. So what was x again? Where's that bucket again? Oh, there's the bucket. Dump the value of the bucket out. You're holding the value 7. Add that to 3, and then we assign that to the value of y. Now here we're retrieving the value of y, saying, okay, give me the bucket with y in it, and you dump it out into the console.writeLine, which we know then will print that to screen. And that's essentially assignment and retrieval of of variables. Okay, so this is a very simple case. What I want to do now is comment out this code. If I were to begin commenting out the code like we learned about in a previous lesson, I could use the 2 forward slashes. I'm going to show you a different method in just a moment, but notice when I do that, something interesting happens. I commented out the declaration for the variable named x, and when I do that, notice I get these little red squiggly lines underneath x's, and if I hold my mouse cursor there, it says the name x doesn't exist in the current context. And we might say, well, there it is right there. It's in our code comment. But remember, we're telling the C# compiler and ultimately the .NET runtime to ignore that instruction. So the compiler is looking at our code and saying, I have no idea what you're talking about x. I've never heard of x before. I don't know what you want me to do with x. And so it raises the red flag and say, I can't continue on under these conditions. You have to give me more information. Obviously, we can fix it by removing the code comments. All right. Now, what I want to do is comment out several lines of code. And instead of just doing 2 forward slashes in front of every line, which can be laborious, I'm going to comment out multiple lines at the same time using a forward slash and a star character over the number 8 on your keyboard to begin a lengthy comment, and then right here before that read line, actually let's go ahead and keep it all together. After that, I'm going to do a star forward slash. And so now we're going to type another code example beneath that. All right, this one will be a little bit more interesting. Follow along. Pause the video if you need to catch up with me. I'm going to try and type fast just to save time. All right, and before I forget, let's go File, Save All. Great. Now, let's begin here at the top. You can see that this is a different style application with some different commands or different uses of commands that we're familiar with. So we're just going to play a little name game, and we're going to ask, what is your name? And we output, type your first name. Now notice in the first case I'm using a right line, which will print what is your name to screen, and then use a line feed character to go to the next line. However, I'm using yet a third method from the console object, the console class, which we'll talk about classes and methods later. But this method is different than write line. This will just write out the statement, type your first name, whatever's in between our double quotes there, and it won't go to the next line. It'll just wait there on that line. And then what we're going to do is create a new variable using a different data type, a string data type. So we're not interested in individual alphanumeric characters, so A through Z, 1 through 0, and the special characters. We're interested in a string of them, or a collection of those characters. So not just the individual character B, the individual character O, and the individual character B. We're interested them as a string or a collection as Bob, B-O-B, okay? So that's what we're declaring a bucket in the computer's memory sufficiently large enough to hold a string of characters, however long that it is, all right? And then what I'm doing is calling our console.readLine method that we're already familiar with, but there's a twist on this. Up to this point, we said we're using the readLine method in order to stop the execution of the application, to wait for the user to hit the enter key on their keyboard, then to resume. However, now we're using it for its real intent, which is to retrieve data from the end user. So in this case, we're asking a question, what's your name? The user types it in and hits enter, and then whatever they typed in is assigned using the assignment operator to the variable we created called first name, all right? Hopefully that makes sense. Now we're going to create a second variable of type string called my last name. We're going to do the same thing here, console.write, and then we're going to allow the user to type in their last name. And then whatever they type in when they hit enter on their the enter key on their keyboard will be saved or assigned to the variable called my last name. Now that we've done assignment to my first name and my last name, I'm merely going to concatenate the values together. So let me point something out. There's several things we need to talk about here. Notice here we were doing actual math where we were adding values together. This is the arithmetic or arithmetic operator. We're basically adding things together, right? Here we're kind of adding things together, but the connotation is different. We're not adding hello and Bob and Tabor with some spaces in there. From a mathematical perspective, we're concatenating strings of characters together to make one really long string. So it's the same operator, but it's used in two slightly different contexts. Kind of does the same thing, but we need to understand that there's a fundamental difference in how operators interact with different data types, okay? You'll see why this is important as we continue on through this course. But at the very end here, we're expecting to see hello, comma, space, Bob, space. Notice that I have in here a additional double quote with a space in between to give some spacing between the first name and the last name, and then obviously my last name here. We'll give that one more line of code to write because we need to do another read line so we can see the value on screen. Let's run the application, and we have some things we want to talk about here. Okay, so what is your name? Type first name, Bob, enter. Type your last name, Tabor, enter. Hello, Bob Tabor. Awesome. Okay, so very simple application, but hopefully now we're pushing the envelope a little bit more, learning a little bit more about additional data types that we can use for our variables, and learning about assignment, that it works with all kinds of variables, and then also learning about operators that work differently with different data types. Now, before we get too far, in the previous example, we used merely X and Y, which we might expect to see in some mathematical context because we're used to seeing those characters used in algebra problems. But whenever we start writing business applications or even games, we need to give our variables names that are meaningful inside of the program that we're writing. So I could have just used called this X and then done something like this X and then done something like this X. And you look at this and you say, I have no idea what X is supposed to do. All right. It's because we used a very vague description of the bucket in the computer's memory. Instead, you don't have to worry about keystrokes. Make it human readable. Write your code in such a way that somebody can read through it and understand exactly what the variables are doing and what the logic of the application is doing. And then also notice as I go and change some of these things back here to my first name, I used a little feature of Visual Studio that allowed me to say, now that I've changed the name of X to first name, let me rename it everywhere that I've used the word X. Did you notice I did that? I hit the control and the period on the keyboard here. Let's do that one more time. I'm going to change this back to X. Notice that I get the little light bulb here off to the left-hand side, which is quick actions. And then I hit control period on my keyboard. And now it gives me the option to rename my first name to X. And it even off to the right-hand side shows me all of these changes. This is called a refactoring. I'm changing the code just ever so slightly by renaming things to give them more meaning. In this case, I'm doing the exact opposite, but we'll come back to that. So do I want to rename every time I use the variable name my first name to X? Yes. So let's rename everything. Bam, just like that. All right, let's rename it one more time. So my first name, control period, and now I want to rename everything from X to my first name. And you might look at that phrase, my first name, and then again I used it down here, my last name, and you're thinking to yourself, that's a crazy naming convention. Well, it's a naming convention that's called camel casing, where you start with the first letter in a list of words that you're kind of munging together to describe a variable or something along those lines. Use a lowercase for the first letter of the first word, and then an uppercase letter for the second and subsequent words in that variable name. So ideally, it makes it human readable. I can read it fairly easily that way. All right. All right. And at this point, I think it's important also to do something like this. I'm going to rename this to my first name, all lowercase. And remember what we said in the previous video, that C# is a case-sensitive language. So if you were to use the wrong capitalization, then you're going to get a red squiggly line and it says my first name does not exist in the current context. Do you remember seeing that just a moment ago when we removed the declaration for X up here when we commented it out? The same thing is true here. My first name, all lowercase, is different from the bucket, the variable we define called my capital F, capital name, first name. All right. So capitalization matters. Make sure that you remember that. So in this case, let's just go ahead and change everything back correctly, and we should be good to go again. Okay, great. Now you might be saying to yourself, well, this degree of precision seems pretty difficult. I mean, how am I going to remember exactly what I named things in the past? There are a couple of different tricks for them. Keeping your code methods small, and we'll talk about that later. That's one way to do it. But then the other thing is to rely on IntelliSense, which is that little code window that I told you to ignore before. It's actually pretty important. So as I start typing notice that it pops up beneath what I'm typing, the correct capitalization, correct spelling for any of the variables that I've defined up to this point that start with the letters MY. Now, at this point, what I can do is simply hit the equal sign on my keyboard, and it will type everything else out for me. So I don't have to worry about spelling. I don't have to worry about capitalization. And you may have noticed while I was typing, I was typing and then using arrow keys on my keyboard, and then you couldn't really see my fingers moving, but I wasn't typing every single keystroke. This is what allows software developers to write code very quickly. Once you get used to relying on IntelliSense, one of the tools that Visual Studio gives you in the text editor to make your typing more accurate and allow you to type much faster than maybe you normally could. Okay, we'll come back to IntelliSense later. All right. The other thing that I wanted to tell you about here, or talk about, is that we cannot define the same variable two times. So let's try this. I'm going to go and do my first name and say I want another bucket in the computer's memory with the same name, my first name, and the compiler says you can't do that. We've already got a bucket. We're going to confuse buckets in memory if we give two buckets the same name. Okay, so it says a local variable named my first name is already defined in this scope. You can't do that. Now, we could do this, but I highly recommend you don't do that because, again, my first name, all lowercase, is different than my first name with camel case. But this would cause a high degree of confusion, so never do that. Okay? Be descriptive with your variable names. Don't repeat variable names. Always stick to a naming convention and never break that rule. And if you follow those little rules, I think you'll find some of these initial issues, they'll just kind of dissipate. You won't have to worry about them. All right? Okay, so what I want to do now is take a look at this second set of code. And then not only are we in line number 22 29 declaring the variable, but then in line number 31 we're actually giving it a value. What if we were to rewrite this little passage of code? So I'll go ahead and comment all of this out. And I'm going to make this smaller. In fact, here's what I'm going to do. String my last name equals console.readLine. And then I will say above that, console.writeLine. Type your last name. All right. Okay. So you can see that I took these two lines of code, 29 and 31, and I combined them together. And so what I'm doing here is not only declaring the variable, but then I'm initializing its value to whatever we retrieve when we call readLine. So this is called initialization. And initialization is important because you want to give your variables a value as quickly as possible. This puts your variable into what's called a valid state, which will be an important idea as we learn to write applications, real applications. But also experienced developers like to write less code, and they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they have to read. And so usually you want to declare your variables as you're using them, and not declare them like some people used to do a long time ago, put them all at the very top of a given method or section of code. And so you should get into the practice of two things. Declaring your variables as you need them in the body of your code, and then secondly, if you can, give them an initialized value immediately after you declare them, like we've done here in line number 34. All right? Okay, so tell you what, let's stop right there. I think we've covered a lot of ground for one lesson, right? Let's do a quick recap and just talk about over a dozen things that we discussed. We talked about what a variable is. We talked about how to declare a variable, how to choose the correct data type. We talked about the int data type and the string data type. We talked about assigning values into variables and then retrieving values out of variables. We talked about the assignment operator. We looked at the arithmetic operator and also the string concatenation operator, which is both just the plus sign. We looked at console.write versus console.writeLine. We looked at the other life of the console.readLine method, that we can actually retrieve the values that the user types in. We talked about camel casing and naming conventions for our variables. We looked at IntelliSense. We talked about how to rename things, how to refactor our code using the little quick action. Remember the little light bulb that we could make changes to by hitting Control and period on our keyboard and then using our arrow keys to make selections and to rename all uses of our variable name throughout our entire code base. We probably talked about a lot more than that as well, but let's go ahead and wrap it up here, and we'll start again in the next lesson. We'll see you there. Thanks.